Hello everyone. Today, one more video on embedded system. This time it is on automotive safety and security. I'm discussing with one of a friend named Nagraj, who is basically a automotive safety specialist working in Robert Bosch. We'll discuss about what are the prerequisites of this career, how to get into this career, what are the job opportunities in this career, and how the future of this career. Let's start the session.
Hello, Nagraj.
Hi Anish,
Okay.
hope you are doing well.
Yes, I'm well. How about you?
Yeah, fine now.
Okay. So you are into automotive Android, automotive safety specialist. You are working as automotive safety specialist in Robert Bosch, and you are having a work experience of around 12 years in the same field. The main intention in doing the session is to make the viewer or to make anyone who wants to take up this career, then he will come to know about various aspects of embedded system. Like my questions for you would be the first one: what are the different domains of embedded system, and what is the role of embedded system in automotive industry, and what is automotive safety, and what is its significant role in automotive industry. Okay, so one by one I'll be asking some questions on embedded system and automotive safety in industry. uh, Let me start with the first
Yeah,
question.
sure.
What are the different domains of embedded system?
Yeah, Anish, all we know, like embedded system is the thing, but a combination of hardware and software, which is developed to perform a particular set of job, or you can say automated job. Yeah, we have actually various domains in embedded systems. But just considering the job market, I just try to name few of them. Yeah, mainly we have consumer electronics and automotive domain, and apart from that, we have medical and aerospace domains. Also, we are there is a huge industries into home automation as well as industrial automation. Yeah, these are the different types of domains in the embedded system.
Fine.
I can just maybe tell why there is a different domains are defined here. It's basically based on the application where it is being used.
Okay. So what is the role of embedded system in automotive industry?
Yeah, as I mentioned, the embedded systems are mainly used to make our job easy because it's automated, and inside embedded system there is a controller which is having software which can do some set of jobs itself, or it is having its own intelligence inside it. That's why embedded system is being used in our daily life, to make our life easy or our jobs easy. If you consider or take an example, one example for consumer electronics, the best example we can take is which we are daily using in our home applications, like washing machine. What it is doing is it is washing the clothes and making our job easy, so that it is such that it is reducing the human efforts. Uh, so, in the same way, in automotive also, we can use embedded system, and so that we can save the fuel of the automotive appliances like car or bus, or it may be the off vehicles like harvesting machines or excavators. So in if you take like in the earlier days of the automotive industry, where the car was invented, that time there are fundamental features in the car, to run the car we need the engine, to turn the car we have a steering system, and to stop the car we have a brake system. So these systems were purely mechanical in the earlier days of the car. Later, the engineers or the car scientists thought that they can introduce the embedded system so into this mechanical system so that they can minimize the effort of the driver who is riding the car. Also, they can save some fuel consumption. So in that way it is thought, and they trying to they try to introduce the embedded systems into the automotive industry.
Okay. So you are into safety role, right?
Correct, yes.
What is automotive safety?
Yeah, the automotive safety, before going into that explanation, maybe I'll give the like brief idea about what is automotive itself, or what is automotive domain itself. Basically, as I explained, in the car, we have the fundamental features which are being used to control the car, like steering system, brake system, engine system, all those things. So here, to control each feature of the car, the car manufacturers, which are called as a OEM in the automotive terminologies. OEMs are nothing but the original equipment manufacturers. So, like we can name few of them, like Maruti, or yeah, Renault, Toyota. These are the OEMs. So the OEM started implementing the embedded systems for each functions of the car. These embedded systems in the car are called as the ECUs, nothing but electronic control units. So these ECUs are controlling the each one of the functions of the car. So I can say like one ECU is dedicated for controlling the brake system, one ECU is to controlling the our engine system of the car, and one ECU is controlling our steering system. Controlling in the sense like human interference will be there, like driver will be using the steering, but based on the steering rotation there will be a sensors which is actually sensing the angle of the steering, and that sensor is feeding into the embedded system, and embedded system is actually rotating the car or car wheelbase using the motor, electrical motor. This is the basic automotive system functionalities. So here we can mainly divide the ECUs. What are the like embedded system? What I call it as in the automotive terminology as ECUs. So these ECUs we can mainly divide into two different groups. One is the safety critical ECUs. The other one is non-safety critical ECUs. Now we'll just look into like briefly what is safety critical and what is non-safety critical. So what I mentioned as like the fundamental features of the cars are nothing but the braking system, steering system, and engine system. These all comes under the safety critical ECUs, or these are the safety critical embedded systems. Because if these fails, right, for example, brake fails, then there will be a probably there will be accident, or there will be surely there will be some hazard will happen to the car, or who is actually sitting inside the car, or we can say them as a passengers. So these are the safety critical issues. Coming to the non-safety critical issues examples, inside the car we have the multimedia system, which is actually providing us the services of radio or music system. Also, we have an instrumental cluster, which is actually displaying the odometer or odometer values or the fuel level, and some if there are any critical signals in the car, that will be displayed on this instrumental cluster. So these are called as means these you can categorize as non-safety critical issues, because if just we'll take example of multimedia or radio in the car. If radio stops working while driver is riding the car, it will not harm anything who is sitting inside the car, because just it will stop and we can just switch off the radio. So we can just categorize them as a non-safety critical issues. So now we can imagine like what is safety in the automotive system. So wherever in the car or in the automotive uh, products where we are actually using uh, we are actually using embedded system to control the safety critical functionalities, there we'll apply a embedded safety into it. So this is how we can just figure out what is safety in the automotive
Okay.
industry.
Okay. So before you also mentioned like safety and security. Uh,
Yeah,
what is the difference? Like, what is automotive security?
yeah. Automotive safety is we are safeguarding our ECU uh, for creating any error. Means if it should not create any error into the car. Like if there is a brake ECU, the brake issue should actually work as intended. Means like brake issue is made for braking the or stopping the car. So whenever the user or driver is actually applying the brake, mechanical brake, the brake issue should stop the car using motor or something, some mechanism is there inside. Using that, it should stop the car. So in that way, in that manner, like we need to apply or we need to follow some guidelines to make our ECU safe. There is ISO standards, like there is a international organization standardization, right? Or international organization for standardization. These people have defined a set of guidelines to develop an issue to make the particular issue safer. So these guidelines talk into like how to code our C. If you are writing the code in C language, how to write a code and what are the measures should be taken to write a code or to validate a code. Same way, like as I mentioned, embedded system is combination of hardware and software. For hardware also, there is a set of measures defined by these ISO people. So they have written the guidelines like how our hardware should be designed, what are the measures should be taken into the hardware such that it should not fail easily, or if it fails, what can be, how it can be handled, or how can detect the failures in this issue. All these guidelines have been set by these ISO standards.
Standard.
So we need to refer the standards and implement into the ECU. This comes under the ECU safety. Now we can see what is security. Security means like it's like a normal our computer or mobile security. For example, as I mentioned, ECU is also an embedded system. It is having the different embedded peripherals, like it will be having communication system which is used to communicate with the outside world or with the other ECUs. These communication system will be usually in the car. It is the broadly used communication system is the CAN based communication system. Also nowadays they are using Ethernet, LEAD, etc. and everything. So somebody can hack this communication system or can bus. They can try to introduce some malware into the ECU so that they can introduce a bug into the issue and it will create some failures in the system and it will create some damage to the vehicle.
Okay.
To avoid this one, we have actually there is a automotive safety standards have been defined where there is a set of measures or guidelines has to be followed such that we can make our ECU safe.
All right. So this is somewhat like antivirus to our system.
We can just assume same way.
Yeah.
Yeah.
All right. All right. Now coming to the main important thing, what actually is required. That is, what are the job opportunities in this area, like automotive safety and security? What are the job opportunities? now in the market?
Yeah, currently the safety and security domain is evolving because the earlier we are having very basic safety critical issues like where in the car we are having steering, brake, and accelerator or the engine systems. Nowadays, more and more features are being adding to the car, like we call it as ADAS systems. In ADAS systems, there are a lot of features being added to the car to safeguard our car. So it will give a lot of features to the driver so that driver can safely ride his car. We can take one like small example. When driver or the driver is driving the car, when he wanted to rotate, sorry, take the car from one line to other line, the generally we need to look into the mirror and take the car into the other line. So in current in the advanced cars, they have introduced a feature using the radar system. So radar will actually monitor if any car or some vehicle is coming behind this car. If something is coming, it is indicating to the driver there is a hazard or risk while taking the car into the other lane. So that driver will get alert and he will not immediately turn his car. He will wait and he will then he can take a car into the other lane. So such features are called the ADAS features.
Okay.
These are being added to the car, and so that's the reason there is a lot of development activities are going on. That's the reason we have a lot of opportunities in safety domain.
Okay. In both safety and security domain.
Yeah. Also, now we are moving from the conventional petrol diesel engine to the electrical engines, electrical vehicles. So in electrical vehicles also there is a battery. So you can maybe you might have heard like in few in the news like some of the electrical vehicle batteries are actually blasting and batteries are catching a fire. So this is because they have not implemented some or they have missed some safety in monitoring the battery, because battery mainly it will blast because of the temperature. So we have to implement some features to monitor temperature of the battery, and we should stop extracting the current from the battery if there is a temperature is actually crossing the limit. So due to that, the safety domain is evolving, and there are a lot of opportunities in the safety domain.
Okay, that's good. One more thing, like if anyone wants to get into this career, then what are the prerequisites of this career? What one should learn? Is there any course like thing so that he does some courses and get into this profession?
Yeah, definitely. Usually freshers they can get into the embedded domain initially, or automotive embedded industry. Then, if their industry is into the safety critical issue development, obviously they will get a chance to work in the safety and security domain. The prerequisites I can say like, yeah, unlike any other embedded systems, for automotive safety and security also, we need to have a basic knowledge of embedded C microcontroller as well as microprocessor. So these are the mandatory skills, I would say, which are required to develop any of the embedded systems. So along with this, ISO, as I mentioned in our previous discussions, ISO has defined a set of guidelines to achieve automotive safety and automotive security in the automotive domain or for the automotive products. For automotive safety, The ISO has defined ISO 262 document where a set of guidelines are mentioned which needs to be referred at the time of automotive product development to achieve automotive safety. So we can just see the definitions of automotive safety as per the ISO here. Absence of unreasonable risk in the EAD systems of the vehicle. Um, Meaning that EAD systems are nothing but here electrical and electronic systems. So these electrical and electronics component or system may cause some errors in the system due to wrong designs or due to the aging of the hardware. So to minimize or to completely avoid these errors, so these errors in the ISO terminologies are also called as a false. To remove to minimize these faults from this ECUs, which are nothing but the automotive embedded system. So we need to follow these ISO guidelines so that we can achieve automotive safety in the embedded system, in this automotive embedded system. So same way for automotive security also, the ISO has set some guidelines in the ISO 21424. So by following these guidelines, we can enhance the security of the automotive system. So along with this, we need to have the basics knowledge of the ECU communication protocols like LIN Ethernet as well, which also help us to understand the automotive domain as well as the automotive safety and security. So coming to the process, we also have the quality control process in the automotive domain, which needs to be carried out across our development life cycle. So the widely used automotive standard process in the automotive industry is the ASPICE, where the best practices have been defined by this ASPICE standards, which needs to be carried out across our development life cycle so that we can minimize errors in the system or product and we can achieve a quality product. So I hope, yeah, this will help our viewers to understand the basics of automotive safety and security.
All right, all right. Thank you, Nagraj, for thank you for sparing your time and giving us knowledge on automotive safety and automotive security domain. You also spoken about different domains of embedded system, and you explained about automotive safety and automotive security, and you also said like what are the prerequisites of this domain. Thank you for giving us this knowledge. Thank you once again.
Yeah, thank you, Harish. Thanks for giving me a opportunity to share my knowledge as well. Yeah, maybe it will help few of you, our viewers as well.
Okay. Thank you, Nagraj.